But it's the only finishes by like 6:42. How you get? I can go. Question. I got some business question. Do you have flashcards in the book? You have nothing.
Okay, so my project was how flame retardants react in a fire. Basic overview of flame retardants is they're used to prevent the starting of fire or limit the spread of a fire once it starts, and to do that it minimizes the damage of the fire. Many flame retardants are used in anything burnable, so electronics, furnishings, vehicles, like construction equipment like the walls here, there's flame retardants in them. So I was focusing on solids. So in solids, the top three flame retardants are bromine, phosphorus, and chlorine. And this is a picture of powder flame retardant of bromine. So the bromine flame retardant, when it reacts, or when it's put in the material, it doesn't react with the oxygen. So it prevents the oxygen from reacting with the fire, and it produces a char around the material so that the fire can't reach the material. It's blocked by the char. And in chlorine, the chlorine actually and the phosphorus reacts with the oxygen, but so the oxygen doesn't react with the material, and that creates some dangerous chemicals sometimes. So how flame retardants work? They work physically, so some flame retardants cool down the material. So to do that, they increase the temperature by which the material needs to be so that it catches fire. And then there's a dilution process where water or an inert gas is released through a reaction so that it stops the ignition. It also reacts chemically. So in the gas phase, the different chemicals in the flame retardant interfere with the chemical reactions in the flame, but sometimes more dangerous chemicals are released, as I said earlier. In the solid phase, they go through a charring. So charring is basically an incomplete process of combustion. So the hydrogen and the oxygen in combustion are used up, leaving only carbon, and the carbon is what makes up the char. The char is harder to burn because it is thermodynamically or thermally stable, so which means that it is stable when it's heated at a really high temperature. And it stops the spreading of a fire by acting as an insulator, and that insulator absorbs the heat when it's in a fire. Intumescence can be added to a char, and to do that, it makes the char swell and become a larger volume while decreasing the density so that it's even harder for the flame to reach the material. And so interchangeability, this means that only certain flame retardants react with certain materials. So a flame retardant that you would put in like the walls here wouldn't be the same flame retardant that you put in an electronic. So there are environmental effects with flame retardants. The biggest ones are called PBDEs, which is polybrominated diphenyl ethers. They're made of bromine. They're dangerous because they're very slow to degrade. They don't break up very easily. And many have been found in salmon, beef, butter, and cheese, which I find interesting is that's kind of like farm-raised stuff. So something maybe there. They're also found in like marine mammals too. But they have hormone disrupting effects, particularly in the estrogen and thyroid hormones, which just affects people's hormones, but there aren't many other side effects besides that. So I did an experiment in which I made flame retardants. So to do this, I put the powdered flame retardant that you saw earlier. I mixed that together with plastic of nylon. I mixed it in an extruder, which is what's on the left. The powder went through the big cone container at the top, and the plastic was in the extruder, and it comes out in small strips of black colored plastic. And once the strips come out, they're cooled in water because they're really hot from being mixed, and they're cut up into small, thin plastic pellets. And those pellets are molded in an injection mortar, which is on the right, and it makes plastic that is to be burned. So with that, there's a picture of the plastic that was burned. I did a UL94 test in which I took the nylon sample of the flame retardant, held vertical to a table, and set a blowtorch on it for 10 seconds to determine how well it would go against the fire. After the 10 seconds, the blowtorch was taken away, and the time that it took for the flame to go out was measured, as well if there were drops of plastic that came onto the cotton ball below, which isn't in the picture. So I'll go to the conclusions. So the picture on the left is what the plastic looked like beforehand, which was being burned right there. The one in the middle is one of the bromine flame retardants after burning for 10 seconds. You can see on the top there's only a slight amount of burning after 10 seconds, and it didn't really fall apart. It worked very well in the fire. On the right, the phosphorus on the bottom, it showed some burning and there were some plastic drips, but some of the samples worked. So when there was a high concentration of phosphorus flame retardant in the plastic, it was less resistant it was more resistant to the fire. But when there were lower concentrations, it wasn't as resistant to the fire. And the bromine, it was basically the same damage done through the fire through lower concentrations and higher concentrations. And the importance of this is that flame retardants have really helped to decrease the amount of fires in the United States. In 2013, there were over 1 million fires in the US and almost 16,000 injuries with over 3,000 deaths and $11.5 billion in damage, which is a lot. But without the flame retardants, people wouldn't have been able to get out of the houses faster or been able to escape from the fire, or there would be even more fires because flame retardants wouldn't be able to stop the fires.
You said like here it says that they cut down on the amount of fires. Like, is there a way to like completely like stop? Like, if you use like enough flame retardants, is there a way to like completely not make a fire in a building, or would that be like impossible and too expensive?
It would be impossible because the fires can start at different temperatures and react differently with different materials. So it would have to be totally different concentrations all throughout. And there are some materials that'll like always catch fire, like paper is going to catch fire.
Are there any environmental effects of the phosphorus?
There aren't as many from the phosphorus. There's one I wanted to do, red phosphorus, but it's explosive. So that's something that I guess could be minor. Yeah. The phosphorus doesn't work as well, but it doesn't have as many environmental effects.
Okay.
Does it all come down to money when it comes to why we don't see a lot of
Yes. There's the bromine is very expensive compared to the phosphorus. So people, when they do flame retardants, they use phosphorus, but at very high concentrations.
Oh, she has a question.
Oh, sorry.
Wait, we put chlorine in pools, why is that?
Yeah, because, well, the water's not going to catch fire.
Yeah.
But when if you were to combust chlorine, then the chlorine would react with the oxygen and release bad gases. Chlorine dioxide is a dangerous gas, but don't know why put it in pools.
Wow.
How that affects it.
Oh, you gave that?
Yeah.